right, so today we're going to still be approximating those areas and accumulating areas, but we're going to use a calculus method called Riemann sums. And today we're going to talk about 3 different methods. The first is the left rectangular approximation method, or LRAM. And so we have some curve above the x-axis. And we want to find the area under that curve. If we're going to use the left rectangular approximation method, we're going to use rectangles, obviously, because it's a rectangular method. And the left corner of each rectangle is going to be on the curve, all right? And the rectangles are like right on top of each other. And we just fill an area with those rectangles where the left corner is on the curve. Right? And to find area of rectangle is not difficult. You're just multiplying the base times the height. And we'll talk about in a second how you find that base and how you find that height. Okay, then for the right rectangular method, same thing. We have this curve. It's above the x-axis. But on the right rectangular method, the right corner of the graph or the right corner of the rectangle is what sits on the graph. Right, and then the very last one we're talking about today is the midpoint rectangular approximation method. And you probably could guess how this works. So on these, we're still going to have a rectangle, but neither corner is going to be what is sitting on the graph. It's going to be the midpoint of the rectangle that sits on the graph. So the midpoint. These are a little more difficult to do. All right, so that gives a good idea. All right, so on this one, midpoint of rectangle is on the graph. Right, for the RRAM, the right corner is on the graph. Right, and then this first part, when we talked about the left corner. Is on the graph. Okay, so let's talk about some ideas. So whenever we are doing this Riemann sum approximation, we are finding areas, and one of those parts of finding the areas is going to be the width of the rectangle. And so you'll be told an interval that you want to find the area under the curve. And then you're going to be told how many subdivisions or how many rectangles that you're going to draw. And so a generic interval is from A to B with n equal subdivisions. So if you want to find the width of each of those rectangles, you're going to take the b minus the a of your intervals. So subtract the larger number minus the smaller number. That gives you the width of the interval. And then you're going to divide that by how many rectangles you're going to draw, or how many subdivisions there's going to be. And that'll give you the width of each rectangle. All right. We also need to find the height of each rectangle. And so for the left rectangular approximation, the height of each of these rectangles comes from the value of the function at that left point. So for the LRAM, we're going to find the height. We're going to evaluate the function at the left endpoint of each, and instead of interval here, let's say rectangle. All right, then for the right rectangular approximation, the value of the height is going to come from the value of the function at that right corner. And so we're going to evaluate the function at the right endpoint of each rectangle. Okay, and then for the midpoint, the height of each rectangle comes from the value of the function at the midpoint. So we're going to evaluate the function at the midpoint of each rectangle. All right, and then the total area, or the accumulation, is going to come from the sum of the areas of the rectangles. Now, one thing we do in calculus is think about if we have an overestimate or an underestimate. So when a function is increasing, so I'm going to draw two increasing functions, and it's a left Riemann sum. So the left corner of the rectangle is what sits on the curve. All right. Now what you'll get for the area under the curve is the area of these rectangles. So looking at that, would you say that would be an overestimate or an underestimate for left rectangular area method? It's going to be under, because those areas don't fill up the whole area underneath the curve. So it's going to be an underestimate. All right, let me do a different color. All right, for the right rectangular approximation for an increasing curve. So the right corner is sitting on the curve. So you really only have to draw a couple before you can see that the rectangles cover more area than the curve does. So if the function is increasing, a right rectangular area method is going to be an overestimate. Okay, so let's look at a function that's decreasing. So you guys draw these rectangles for a decreasing function. It could be concave up or concave down. I don't know why I chose to do concave up on all of these, but either concave up or concave down or linear. a decreasing function. Draw your rectangles for left and for right and determine if they are over or under estimates. All right, so you should see that on the left Riemann sums, if a function is decreasing, the area comes above where you want it to. So that's going to be an over estimate. And then for the right Riemann sums, there's a gap here and here that the area is not covered. So it's going to be an under estimate. Now that is something they ask on the AP test. And we'll learn another type of approximation tomorrow. But what I do is I just draw it. If I can't remember, I just draw. It'll tell you it's increasing in concave up or increasing in concave down or something. And I would just draw it, or maybe in its actual function, you need to know what it looks like. But anyway, and then I draw the left Riemann sum or the right, whatever they're asking, and then you can tell pretty easy if it's over or under. All right, so let's do some check for understanding. So we're going to consider the region enclosed between the x-axis and the curve y equals e to the x. Now, I want you guys to know what that looks like without a calculator. I'm not sure what you remember about e to the x, but it's an exponential function, and it's going to be increasing. We're going to go from -1 to 4, so I'm going to draw a little bit over on the negative side. And so e to the x is kind of flat on the left side, and then it increases like that. Now we want to go, so approximate the area under the region between -1 and 4. Okay. So this one, it's fairly obvious what the width of each of your rectangles is going to be, but I'm still going to go through the process because sometimes it's not obvious. So the width of our rectangles is, we're going to subtract the right side of the interval minus the left side and divide that by how many rectangles we want. So it ends up being 5 over 5, which is 1. So each width of our rectangle is going to be 1. All right, we are going to do it doesn't say. Oh, yes, it does. It says use a left Riemann sum. So the left point of our rectangle is going to sit on the curve. So I'm going to start at -1, and the left point is going to be on the curve. Right, and then 0, the left point is going to be on the curve. And then at 1, and then at 2. All right, and so we are trying to draw 5 rectangles that cover the area between -1 and 4. And so what people get confused about is they try to draw another rectangle at 4. If we needed to go to 5, we would do another rectangle at 4. But as soon as all the area is covered between -1 and 4, then we're good. We've covered the section we need to. Now there are some gaps because this isn't a perfect science. This is an approximation method. All right, so what we want to do is add up all these areas. So we're going to do the width of each rectangle times the height of each rectangle. Now the width of every rectangle is 1. All right, and then the height is going to come from the value of the function on the left side of each rectangle. All right, so our function is e to the x. So that height of this rectangle right here is going to be e to the -1 because our x value is -1. All right, then we'll go to the next rectangle. The width of that rectangle is 1. All right, we want the height from that rectangle is going to come from the value of the function when x is 0. So that would be e to the 0. Okay, the next rectangle, the width is still 1. The height of this rectangle is the value of the function when x is 1. So it's e to the 1. All right, we're going to keep going. The next rectangle, the width is 1. The height is the value of the function when x is 2. And then our last rectangle, this rectangle right here, the width is 1. The height is the value of the function when x is 3. Okay, so then we would just use the calculator, add up all those values, and you should get approximately 31.561. Okay, the B part, we have the same region, but we have a different approximation method. We're going to use the midpoint approximation method. I may have drawn it a little different, but that's okay. All right, I still need to cover this area under the curve between where x is -1 and x is 4. Now I may have some above, some below, but that's the area I want to cover. All right, so this time I want my point of my curve to be on the midpoint. So I'm looking for the midpoint between -1 and 0, which we'll say is about right here. Maybe let me change colors. About right here. All right, so I'm going to draw a rectangle that's the height. Okay, and then the midpoint between 0 and 1 would be about right here. So I draw a rectangle with that height. Okay, and then I would just continue this. Okay, now we can't really figure out over or under with midpoint because some of our rectangle is above and some of it is below, so it kind of averages out. Okay, so now when I go to find this area, my widths are all still 1. the height is going to come from the point that's at the midpoint. So the midpoint between -1 and 0 is -0.5. So the value of the function when x is -0.5 is going to be the height. All right, and then my width is still 1. The height of the next rectangle is the point between 0 and 1, which is positive 0.5. So we're just finding the value of the function at that midpoint. So this last midpoint is between 3 and 4, which is 3.5. All right, and then this is an approximation of 52.035, and that's just from typing it in the calculator. All right, so on some of your assignment, the first 3, that's what you're gonna do. Like I would just do a little graph and I would figure out my width using this. And I would go ahead and draw my rectangles and then do the area, the width times the height of every rectangle. And then part of your assignment is going to come from a table. Now, the AP people really like using tables on their assignment. Now, you can't see it, but we have decimals here, so I'm going to draw them in. Hopefully you can see it on your paper. Okay, so the rate at which water flows out of a pipe in gallons per hour is given by R of T. Selected values of R of T are shown in the table. We're going to use a right Riemann sum approximation with 4 equal subintervals to approximate the area under R of T from 0 to 24. So let's start off and find our width. So we would take the right part of our interval, subtract the left, and divide by how many subintervals we want. So each width is going to be 6 units long. Okay, so if I'm dividing my table into 4 equal subintervals, 6 units long, this would be the first, second, third, fourth. So each of those is 6 units long. Okay, so I'm going to do the same thing on the other side. All right, now I do know my width of every rectangle is going to be 6. I need to know the height of every rectangle. And this is organized vertically. And so technically what would happen is this would be the left. This would be the middle or the midpoint. And this would be the right in each one of our different sections. Right, so the top one of the section is what would be on the left if it's horizontal. The middle one would be what's in the middle, and then the bottom one would be the right. And what we want for this one is the right. Okay, so for our first area, rectangle, remember the width is 6, and then the height is going to be what comes from the right point, which would be 10.8. Okay, we go to the next rectangle. Our width is 6, and then the right point is going to be this 11.4. The next rectangle, width is 6. The right is 10.7. And then the last rectangle, the width is 6. The right is 9.6. Okay, and then you can use your calculator to add all that up. It should be 255. Now this table actually means something, and so that's what B asks. What does this area represent? So when we're accumulating these areas of a rate function, so this is gallons per hour, and then our time is in hours. Remember that you can find the unit by multiplying gallons per hour by hours, and so that leaves us with gallons. So this 255 is gallons. We're accumulating gallons. And we're going to go back and look at what the problem is. So this is gallons of water that has flown out of the pipe. So 255 gallons of water flow out of a pipe over, and then we need to talk about how many hours it is. So from 0 hours to 24 hours. So that would be 24 hours. Or you could say from 0 hours to 24 hours. Either one is fine. All right, so what I want you guys to do for your assignment is these 6 problems down here. Now, obviously, you need to do them on another sheet of paper. 4 through 6, if you want to do on here, you can. But when you turn it in, you'll also be turning in your notes. So I would go ahead and just do it on your own paper.